I am going to start the new concept. The first time you are going to know about the number, that is irrational number. Irrational number. Irrational number. So what is the definition of the irrational number? The number which is non-terminating and non-repeating the number which is non-terminating and non-repeating. That means what? The example is root 2, root 3, root 5, pi, etc. Fine. Now, why they are irrational number? Because if I want to go for the decimal expansion of these numbers, they will give you non-terminating, non-repeating decimal form. Now, you know about the terminating. This is a vital word, and this is non-terminating, non-repeating. So now I am going to tell you what is the meaning of terminating and what is the meaning of non-repeating. Okay. So I'll give you the example of repeating. So how it possible? I am going to find the result of half. So half means 1 divided by 2, 0.05, 10, cancel. Whenever in any long division you will be getting the remainder as 0, that is known as terminating. So this is terminating. Now I am going to divide 1 by 3. If I want to go for the long division of 1 by 3, then 0.03910 and so on. So 1 by 3 means 0.3 bar. Basically it is 0.33333, it will move. So 0.333 means 0.3 bar. So this is non-terminating but repeating. Non-terminating but repeating. So from here we can conclude that all the terminating numbers and all the non-terminating repeating numbers are rational number, and non-terminating non-repeating numbers are irrational number. So we got the alternate definition of the rational number. So what is the alternate definition of rational number? Terminating and non-terminating repeating numbers are rational number. Done. Explain. Locate root 2 on the number line and locate root 3 on the number line. That means how we can able to locate root 2 and root 3. Okay. So basically root 2 is an irrational number, but geometrically root 2 is a diagonal of the right triangle whose sides are of measure 1 unit. That means if I am going to consider this the right triangle and this is 1, so its hypotenuse, this is root 2. Okay, but I have to draw this root 2 on the number line. To draw this root 2 on the number line, let me draw a number line. So I am going to draw a number line. This is 1, this is 2, this is 3. Okay, this is 0, this is 1, this is 2, this is 3. Now I have to draw a right triangle here whose base is 1 as well as whose height is also 1. So this is 1, this is 1. So what is this? This is root 2. This is root 2. Because this is 1, this is 1. This is the hypotenuse. So this length is root 2. This length is root 2. This is OAB. Now I have to reflect this length on the number line. How I can able to reflect? So this line is reflecting on the number line. This is C. This is OC is equal to root 2. Fine. Now from this we can able to draw root 3 also. How is possible? Now if this is root 2, that means this length is root 2. So now I am going to draw one perpendicular here whose the length of the perpendicular is 1 centimeter. So I am going to draw. Okay. So now this is root 2 and this is 1. Now I am going to join. Now this is a right triangle where this is O, this is C. Let me write this is D. Let me write this is D. Any problem? So what is OD? OD is the hypotenuse of the right triangle whose base is this and whose height is this. So if I need to find the value of OD, it is root 2. So base is square means root 2 whole square plus 1 square. So root 2 square 2 plus 1 is equal to 3. That means OD is equal to root 3. Done. It is done. So I got the value of OD. OD is done. And the OD is root 3. So I got the value of root 2 and root 3. Now in the next exercise there is a question. Locate root 5 on the number line. Okay. So basically what is root 5? How we will be getting root 5? Base is 2, 2 square 4. Height is 1, 1 square 1. 4 plus 1, 5. Hypotenuse is root 5. So to draw root 5, I am going to draw a number line. This is 1, this is 2, this is 3. This is 0, 1, 2, 3. Now, you know this is 2, 2 square 4 and this is 1. Fine. 2 square is 4 and 1 square is 1. So this is 5. So what is this? This hypotenuse is now root 5. 2 square 4 plus 1, this is root 5. This is OAB. So OA is equal to root 5. Let me reflect it on the number line. This is, I am going to draw number line. So this is D. OD is equal to root 5. Now if I need to draw root 6, what I will do? Here I will draw one perpendicular of 1 unit and I will join with this. Done. So this is E. Then OE is equal to root 6. OE is equal to root 6. Now how we can able to draw root 7? Again, let me draw an arc. This is root 6. Root 6. This is 1. Root 7. Now I need to join. This hypotenuse will give you root 7, root 7. So it was root 5, it was root 6, it is root 7. I have to reflect root 7 on the number line. How it possible? Yes, it is root 7. So if I will consider this point as E, so OE is equal to root 7. OD is equal to root 5. O, consider this is F, then OF is equal to root 6 and OE is equal to root 7. And by the similar manner you can draw all the numbers. There is one more procedure. That procedure is known as square root spiral. You can do all these numbers by square root spiral also, but this rule is little bit lengthy and little bit tough. And square root spiral is one of the part of our lab activity. In our lab we used to do the square root spiral by using the butter paper folding method, but I am going to explain you once the square root spiral. By square root spiral. Okay, so if I have to draw the square root spiral, then I have to start by root 2, the same manner. This is 1, 2, 3. This is 0, 1, 2, 3. Now I am going to draw 1 here. So this is now root 2. This is now root 2. Now what I am going to draw, I am going to extend it. Now at this point I am going to draw 90 degree. This is 90 degree. Now here this is 1 unit and you know this is root 2. So if it is now right triangle, that means if I will join here taking this one, then it will give you the hypotenuse. So let me take 1 unit. So I am going to join this. So what is this? This is root 3. Now I have to reflect this root 3 on the number line. How it possible? Yes. Just before 2. This is 2 and this is just before 2. This is O. Let me consider this is A. So OA is equal to root 3. Root 3 is equal to 1.732. It is 1.732. Okay. Exercise 1.2. The first question is a true false question. Every irrational number is a real number. In my first lecture I told you that rational and irrational together will form the family of real number. So every irrational number is a real number. It is true. So first one is true. Now second one. What is second one? Every point on the number line is of the form root m, where m is a natural number. Every point on the number line. Okay. If I will write root over minus 2, this number we can't able to draw on the number line. So this is false. Can't represent on the number line. Done. Now I am going to start third. What is they said in the third? In third question, they said that every real number is an irrational number. They said about the real number is an irrational number. This is also false. Because real number consists of what? Real means rational and irrational. So real numbers are not only rational, they are also irrational. Real numbers are not only irrational, they are also rational. So this is false. Now I am going to start second question. What they said in the second question? Are the square root of all positive integer is irrational? Okay. Root 1 is equal to 1. This is rational. What they said? Are the square root of all positive integers irrational? If not, give an example of the square root of a number that is a rational number. Okay, alright. Root 1 is equal to 1 is a rational number. Again, root 2 is irrational. That means what? The moral of the story is that under root of a square number is rational and under root of a non-square number is irrational. Now root 5 can be represented. This question is done, and question number 4 is also explained earlier. That's all.